Hi, it's Tyler. We're here for Behind the Bumpers show, where we take a look more about what's going on with teams and the robots and the passion they have behind it. And we're here today with team number 4334, the Alberta Tech Alliance, coming in from Calgary, Alberta, Canada. This team, Regional Chairman's Award winners back in 2014, 6 regional wins, and even a division win as well, too. And we're here with Cole, Nick, and Studi. They're going to tell us a little bit more about their robot and how they're tackling the at-home challenges.
Giving you a voice,
making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Cole, starting out on this robot here, give us a little bit of breakdown about some of the mechanisms that come in. I know you're going to be talking about some of the intake and then also the magazine in your robot as well.
Yeah. So right here is the our intake. It's got mechano wheels to pull in the balls, the power cells from like any side, and then so it pushes them through into the magazine, which pretty much holds, how many balls was it again? Yeah, 5 balls. Well, it can hold 5 balls, and then it brings them all the way up to the shooter right here, which shoots them out.
So tell me a little bit about maybe some of the intake process. It looks like you have some polycord or a lot of polycord on there, a couple compliant wheels as well too. What made you choose to go that route?
Well, the polycord we're using, because it's pretty kind of easy to work with and can grip the power cells pretty well.
And one of the things we'll be talking about on this too is that this is your 2020 robot, but you're looking at doing some modifications. We'll touch on that a little bit later as well too. So let's move on. Studi, I want to hear about the shooter, something really cool, an adjustable hood shooter. I'm a big fan of robots who can have a lot of versatility to it. So tell me about what's going on with the shooting mechanism on your robot.
Of course. So the shooter is something we're really proud of on the robot because it took a lot of time to CAD it out and build it. The biggest feature, as you mentioned, is the adjustable hood. So the hood can actually move up to 90 degrees to help the drivers get the angle of the ball. So here we have some Coulson wheels, and it runs with 2 Neo motors. So essentially, as Cole mentioned, the power cell comes in through the magazine up till the shooter here. And here, the drivers have the ability to aim where they want to shoot the ball at what angle. And then it automatically shoots it out. So it shoots the balls out into there, and because of this, it's a really quick and automatic process, which makes it easier for the shooter and the driver. So we're really proud of that.
So one thing I want to ask you on the shooter, so from the driver and the operator, is do you have set positions, or is it just completely adjustable? How does that work?
It is completely adjustable. However, there are some set positions that we've developed over time because we found they have the best angles. But yeah, it has a full range of motion from 0 to 90 degrees.
All right, so we're going to move on to Nick here, and we touched on kind of some of these components as we go through, but Nick, you guys have a full automation process to make it easy on your drive team from intake all the way to exiting and shooting. So you kind of run me through, and I'd love to see a power cell go through and how that process works too.
All right, so pretty much we made it so that all the operator has to do is press one button in order to intake and then shoot the ball. So if you guys could run the intake mechanism. So pretty much what it's going to do is it's going to go into the robot, right? And it's going to go all the way to the top here. So just keep running it all the way in. Yeah, it's all the way to the top. So pretty much this mechanism right here loads it into the shooter once the shooter reaches a certain RPM. And we also make sure that the balls don't go too far and don't jam by using this Lidar sensor right here. Yeah, so it's
Talk to me about that. Why'd you pick a Lidar sensor for that versus like just like a photo gate or something like that?
More accuracy. So yeah,
So with the automation process, and I'd love to see if you can put a couple balls through and actually shoot them would be great as well too. But one thing I want to ask you with the automation process is what was some of the maybe difficulties you had developing that? I mean, I'm sure it didn't work the first time, right? So can you tell me a little bit about some of the trials you've had as you've been developing this?
So I can answer that question as during my senior year, I was the one who developed that in 2020. The issues we faced with that was the occasional just speed of it. Sometimes it actually went too fast that it just skipped by the LiDAR. So we actually had to slow down the conveyor belt system since it was performing actually surprisingly better than we actually intended it to. So we had to adjust. We had to tame it down in speed.
When you guys are playing a match, are you specifically looking for the inner port? I know from an adjustability standpoint, is that your main focus every time?
That's the goal with the hood. In our Victoria Regional, we had set points set for the hood to go to, so that it would try to hit the inner port as often as it could. Makes
a lot of sense. So I want to go back over to Studi and talk about the at-home challenges we come through. So we talked about, really 2020 as a base, and it's great to see your robot from that perspective. But Studi, as you look at 2021 with the at-home challenges, I know you said you're at the spot where you're just trying to analyze. So talk to me about the challenges, how you're looking at analyzing them, and then what maybe modifications you're looking at making to your robot, if any.
Of course. So as you can see on the board, we're talking about some of the challenges that we can do. In particular, we're looking into doing as many as possible, really. The Galactic Search Challenge and the AutoNav Challenge sound really interesting because as a team, we're really strong in our autonomous systems. And because they're so similar, we're really looking into how we can upgrade our programming and the things behind the robot to help with that. In addition, we're also really into the Galactic Search Challenge, and to do that, we hope to modify our intake to make it more available and easier to take in the balls at a quicker and faster rate. For the Interstellar Accuracy Challenge, shooting from each of the zones, as we mentioned, we're really proud of our shooter, and we're really excited to get that going. And then lastly, for the PowerPoint Challenge, because that involves a lot more teamwork and driver connection, we're really hoping to hone in on our skills to help create the better connection between the human players and the driver station along with the robot.
Is there anything on the robot that you're like, hey, this from what last year's robot would not be compatible with doing any of these challenges so far? Like, is there something you're like, hey, we just need to completely take off the intake or something like that?
Right now, as we mentioned, we're just getting into the logistics of it, so far nothing much. However, possibly the color sensor needed for the power wheel we might adjust and remove depending on that. But yes, I think that's all for now.
Perfect. Well, thank you, Studi. And we're going to wrap up here. We mentioned that you've won the Chairman's Award prior, and Chairman's Award is a lot about inspiration, growing and developing teams out there. And ATA has done a great job of doing that, both with another FRC team, with FTC and FLL. So Nick, wrap it up here. Talk to me a little bit about some of the inspiration that ATA has done.
So in the space we have 5015, the FLL team that's in here, Electric Sheep, and 3 FTC teams. And pretty much what we want to do is teach a bunch of students all the way from FLL to FRC level.
Awesome. Well, ATA, thank you so much for taking the time to tell us about your team, your robot, how you're looking at tackling the at-home challenges. Can't wait to see what you come up with, and we look forward to checking with you later. Good luck.
Thank you so much.
Thank you so much.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.